Are you ready to level up your future? Every Saturday, PDTV brings you maths class on PDTV YouTube channel, the place where knowledge meets opportunity.
High schoolers, level up your brain. PDTV maths sessions every Saturday. Algebra, fractions, equations, functions, all made simple, all made fun. So you all jump on the bus, let's go to where your future is bright. No matter what we say, no matter what we need, no game, no gimmicks, just knowledge we are defend.
Testing.
PDTV maths every Saturday.
Good day, everyone. Good day. How are you doing? Google Meet people, how are you doing? Let me know if my audio is doing well. Google Meet people who are here, please give me some feedback on my audio. All right, so in the meantime, we'll allow some other persons to join. All right. I am soliciting feedback for my audio. So guys, please let me know if my audio is doing good. All right, so, and for the persons who are joining us for the first time, this is how we do it on a Saturday from 1 p.m. to 2 p.m. Join us live on the PDTV channel for mathematics class with Mr. Thompson. And if you guys are not asking a question or commenting, please keep your mics muted. All right? Please, I'm asking for some feedback in terms of the audio. So persons on YouTube, let me know how it is going. Let me check out that space. All right. Let's see. All right. So to my YouTube people, welcome, guys, welcome. How is my audio on YouTube? Please provide some feedback. Google Meet people, how is my audio? All right, we're gonna kick things off. Okay, thank you very much for that feedback. Let me see who we have in class today. So, Logan, welcome. Jada Barrows, and Francis. That's good. All right, so in terms of our YouTube space. All right, thanks for the feedback, Janet, on the audio. Persons who are asking for the Google Meet link, the producers just sent it in the YouTube stream chat. All right, so before we move on, I just want to let you guys know that the factorization topic that we were on in previous classes, I have created an extensive video on that concept, and it's on my TikTok math account. All right, so if you want to learn things at your own pace, no rush, self-pace, I'm going to provide you guys with the link to that video. nice 20 minutes video, and it's just a part 1 of a 2-part video series. So that's a lot of information in that video. So without further ado, let's kick things off. All right, so let's head over. So you guys might see the new topic on screen. All right. Okay, so persons who are not on TikTok, I have a YouTube account as well. So I'll put the video there, and if you're using the IG space, I'll put it on Instagram as well. So don't stress about it. Okay, so our new topic that's on screen. You guys might be wondering what is happening here. So it is still in the realm of algebra, right? Yes, and algebra is a very wide array of topics. But what I do is I kind of target more basic concept that is necessary in order to manage more advanced material. All right, guys, so that's basically how it is done here. So let's move over. So for the learning objectives, by the end of this session, you will be able to state the 3 laws of indices correctly. All right. Let me see. You will also learn how to apply the 3 first laws that we're going to look on, which are the product law, the quotient law, and the power to power law. So those might sound a bit massive, but you'll soon realize that those are just basic concepts that you guys will definitely master. And after learning these laws, you will then know how to use them to solve higher order mathematics problems. All right, so that's basically how we'll go about this. All right, question now. I'm going to put the word law right here. L-A-W. This is for you guys out there. Google Meet students and students also on the YouTube space. What do you understand from the word law? L-A-W, law. All right, so we have 6 branches here. We're going to fill them all out with your responses. So what do you understand from the word law? Come on, guys, let's not boring up the class now, man. Law, L-A-W. You've been watching television, and you've been doing a lot of online work as well. So what do you understand from the word law? L-A-W. Let's go. Google Meet. Let's law. What do you understand from the word law? All right. Okay. Responses are coming in. Let me accept these people. I see. Okay, so somebody says rules, legal matters. Perfect. So let's put those in the concept map. Yes, this is how I do it for some of the lessons, because once the session is through, you guys should attend school in the morning with a fresh mindset, fully loaded with algebraic concepts. So law, I see legal matters. Perfect. L-E-G-A-L. matters. I also see rules. Nice. We have 4 more spaces to go. Rules and regulation. Perfect. Rules and regulation. Let's put REG. We have 3 more to go. Let's see what Google Meet is saying. 3 more to go, guys. 3 more slots to fill. Let's see what my Google responses are. Boom. Law is something that we follow. Our rules. Perfect. Nice, nice. You guys are getting there. All right, so let me fill these in. So laws, so you follow the law. Follow the laws. Our rules. Let's see on YouTube. Okay, great. I see penalties. Okay, nice concepts coming out here. Penalties, correct procedure. On the bright side. Correct procedure. Perfect. So now you guys are smart that we filled all 6 slots within a short space of time. Persons asking for the link, check the stream chat. The link has been posted. All right. 6 responses. Also regulation. Perfect. Let me put that in. Oh, you man, I have it. Rules and regulation. Fine. All right. So the same concept that you guys have. The same concept that you guys have of the rules, regulation, laws, penalty outside in society. That's the same concept we're going to explore for this session. But you know, Mr. Thompson, I got twist it and turn it and make it more applicable to the mathematics space, because that is what we do. We link concepts of real life scenarios to complex mathematical topics so that you guys can understand where this is all coming from. So let's see. So 1, 2, 3, 4, 5, 6. All right. So for one that says legal matters, legal. So you have to be abiding within the legal realms of society. So once you talk about law, you have certain laws that regulate society. If you want to abide by those laws, you have to do things that are legal. So if you do illegal activities, they're going against the law. All right. So I just want you guys to catch what's happening. And you provided these responses, but I'm just giving you my side of the coin at this point. So you played your part already. So now I'm just going to use what you gave to bridge the gap between your responses and the topic. 2 says rules. Perfect. Rules. Rules at school, rules in society, rules. If you break the rule at school, let's say a teacher have a rule sheet listed on the wall. Do not bring cell phones in class. That's a rule, right? So if you bring in the phone and you're using it excessively, there are penalties for the rule, all right? Number 3 says rules and regulation, basically the same as number 2. 4, follow laws and rules. You have to follow them. Ensure that whatever procedure you're demonstrating, ensure that the rules and laws are being implemented in your behavior. It's again a problem. And the problems that you find yourself in now are aligned with penalties. All right? Break the law, speeding, to get a speeding ticket, that's a penalty. Probably put you in jail. 6, correct procedure. Perfect. You have to doing things the correct way. So now you must be wondering where all this social study, society information have to do with math. So let me just break it to you. There are rules that govern mathematical concepts as well. And just like the teacher who have the rule that says no use of cell phones in class, if you follow the rule, class finish and everything good, you're not getting no problem. But if you bring in the phone, dip on TikTok, play music and all sorts of stuff, there are penalties. Now, mathematically, these rules are referred to. So these rules or laws are referred to as laws of indices. All right, we're going to dive down into what these are. So you guys got the understanding of the word laws already. So we know what laws are, as in the overall concept of laws. But now we're going to tie that into the concept of indices in mathematics. I must be wondering where this Chinese word come from, indices. Don't worry, you guys have been touching on it already. But I'm just formalizing what you already understand so that you can have a better understanding in terms of when and how to apply this concept. So we're going to be looking on 3 laws of indices. These are procedures, laws, rules that you perform whenever you are carrying out certain mathematical operations. And we're going to look through extensive amount of examples for this concept. So let's look at the first one. First law. Well, these are the 2 that we'll cover. So the first one, there is some multiplication and addition, second division, subtraction, and then the third one look like rocket science. So we're going to dive deeper into each of those at this point. Okay. Let's not look at the problems as yet. Let's focus only on what is at the, let's just focus on this for now and the definition. So the first law of indices is called the product law. Now, product is the same thing as multiplication. All right, so if you say product, you basically see multiplication. So product law, also known as the multiplication law, that's the first law. And that law says add powers when multiplying same base. No. Don't worry yourself about that, man. That's easy. You're going to get it right now. Add powers when multiplying same base. So if we look at this expression here, we're looking at this now. AM, or a to the m power, multiplied by a to the n power. So we have m and n in this scenario. Now, this is the general rule. So what the definition said is actually being demonstrated here. We add powers. Now the powers are these little things at the top. So the top right hand side, those are the powers. All right. And before we even go any further, let's put something right here. So we have 3 names for those. So one is the power, P-O-W-E-R. Second one is the index, I-N-D-E-X. And the third is called exponent, E-X-P-O-N-E-N-T. So those 3 words can be used interchangeably whenever we are referring to those little numbers at the top right hand corner. All right, so please bear that in mind. So we have 3 words that we can use. So in this case, if you notice, so it's a add the powers when multiplying same base. Same base meaning those big numbers are letters down here. So this is the base. That's the base. All right. B-A-S-E. That's the base. And the little numbers at the top, as we already know, is either the power, the index, or the exponent. Let's just put power for now. So once we are multiplying two quantities that have the same base, we simply keep the base the same. If you notice, we didn't change the A. So A and A are in the base, so we keep the base the same. So we keep the A and we add the power. That is why we have A, and then we have M plus N at the top. I'm going to keep that on screen so you can see what's happening. All right, so once the bases are the same, keep the bases. At the first example, we have x cubed times x to the power of 4. What do you think will be my next step for this one? So let's start solving some problem now, guys. So for the first one, that says x cubed times x to the 4th power. What's going to be my next step for this one? Let's go Google Meet, YouTube, chat, let's go. The roosters are always running around the place, but that's what it is. All right, add the powers. So I'm seeing something here now on YouTube. This is Sue. Sue says add the powers. That's 4 plus 3. So right, so we add the powers. So what do we do with the number, with the base? What's the base in this case? What is our base in number 1? Or what are the bases in number 1? What are the bases in number 1, guys? YouTube stream. Come on, we did multiple of these. So we keep the base, which is the x. So all right, so the x is perfect. Our base is x. Our bases are x. So we keep the base, so we're gonna have x, and it says add the powers, 3 plus 4. So our answer comes out to be x, 3 plus 4, 7. That's it. That is it. That's the first problem for the product law. Now, always remember that I start out pretty basic, but we move our way up to more advanced terms as we go along. But once the topic is brand new, I always tell the students, catch it while it is fresh. Because once we start to move up, you're going to be missing foundational concepts that we need to move on. So I want you guys to work on number 2. Same procedure. Don't do any crazy multiplication. Apply the same procedure that you did and work on number 2. Let's go. Google Meet space. I need to be hearing you guys. That's why we have the Google Meet session, so that you guys can have direct interaction. We're not going to be doing the Meet all the time if you guys just come on here to take up the bandwidth space. All right, so number 2. All right, so before we move today, so I'm seeing Sue. Sue is saying 5 plus 2 equals 7. So before we move to the exponential or the exponent process, let's do the power. Let's do the base first. First, we just need to focus on the base to see if they are the same. Once the bases are the same, perfect. Our rule can be applied. So 2 to the 5th power and 2 square. So perfect. Bases are the same. 2 and 2. We keep it. Right? So we keep the 2. And now our powers are 5 and 2 at the top right hand corner of each number. Based on our rule, if we are multiplying power numbers with the same base, we're going to add the powers. So 5 plus 2 at the top. And that's going to give us 2 to the 7th power. Might seem pretty straightforward, but I have my way of flipping the switch for you guys to access more higher cognitive mathematical abilities. So 3, 4, and 5. What you guys are going to do is you're going to come up with 2 problems that look like number 1, where we have x and we have the power, and 2 that look like number 2. So let's go. Let's keep it moving. So you're coming up with 2 problems. Sorry, 4 problems in total. 1 that is similar to number 1, and 2 that is similar to number 1, and 2 that is similar to number 2. So let's go. We're giving the guys 1 minute to get that done. 4 problems in total. 2 similar to number 1, 2 similar to number 2. Google Meet space. Let's get this done. Francis from Google Meet. Logan from Google Meet. Let's go. Francis, what's your first example? Logan. Example. I mean, even the rooster give him one example, and you guys are just in the class, not really at least trying, but I'm not gonna stress over that. Just gonna move through. All right, YouTube space, what's your first example? So 2 examples that look like number 1 and 2 examples that look like number 2. Let's see. YouTube, give me some emoji in the chat, man. YouTube, let me see some emoji. The chat look boring, someone. YouTube, we need the emojis in the group, in the chat section to bring some vibes to the class, man. The emoji them actually free on YouTube. Give it some emoji. Based on how it looks from my end, it kind of have a, all right, so problem, x squared times x to the 5th power. All right, that's the first YouTube. That's the first YouTube example. So I'm gonna put it at number 3. So it says x squared multiply. All right, I'm going to put a dot for the multiplication, guys. All right, so I don't confuse with the x. So this means multiplication as well. All right, x to the 5th. All right, so x squared multiplied by x to the 5th. All right, let's just fill out the problems for 4, 5, and 6, and then we solve them as we go along. So 3 more problems, and then we start solving them. So thanks for that first one. So we have 3 more to go for the product law. And guys, remember, we're covering 3 laws today. So I need to be moving a little bit more speedy. All right, so next problem I'm seeing is, I'm gonna put that at number 4. 6 squared times 6 cube. Nice. All right, so now I'm seeing one for number 5 as well. So y, perfect, y to the 4th times y to the 5th power. Nice. One last one for number 6 now, guys. Then we move into the solution portion of what we got going on. Come on, guys, let's go. One more for number 6 and we move on. Google Meet people, we move kind of lazy right now, man. Look on the examples on the board and just give me something that looks similar. That's basically what you're being asked to do. And if it's as basic as that, and you can't make up one simple expression and give me, I'm gonna just be more hesitant in terms of who I allow to join the session. Let me just make that clear. Yeah, man, because we work right over here, so man. All right, let me see. Okay, let me see. Let me see what I go on the chat section. Okay, Jada Brown, 7 to the power of 2 and 7 to the power of 3. I'm gonna take that. All right, so 7 to the power of 2. I'll take that from Jada. So 7 to the power of 2 times 7 to the power of 3. Perfect. So we'll use those problems on screen. The font, make the font for problem 5. Perfect. You can fix problem 5 here. I'm going to fix up problem 5. Problem 5. And the eraser move lazy for problem 5. All right, let's see. So let's see the solutions that you guys have for number 3. I'm seeing. All right. Based on what you guys are given. So x to the power of 2, or x squared times x to the 5th power. What's our procedure for that one? Equal. What's our answer for this one? So we're looking at number 3 now, guys. We're going through the solutions right now. I'm going to rewrite number 5 for the person who is requesting. So first thing we do, we check the bases, because if the bases are different, then that's a different type of mathematics. So we check the x's. X is the same here, x is the same here. Perfect. So that's the first thing that we do. Once those are the same, then that tells you that we can our rule or our law. So we keep the x. Perfect. Look to the top. What are the powers? The powers are 2 and 5. So we add those. 2 plus 5. And remember, guys, we are doing laws of indices. And our answer becomes x to the 7th power. Laws of indices, that's important for you guys to remember. And ensure that you're writing down the examples as soon as I complete it, because you're going to need to have something that you can go back to look at, to refresh your memories of what was done. Perfect. So that's number 3. Let's move to number 4. Right, I'm going to kind of move through this a little bit more speedy. All right. So number 4, bases are the same. So we're on the law of common base. Bases are the same, or the bases are common. So that is 6. So we keep the 6. All right. And then our 2 in the top and the 3, that would give us 2 plus. So that's basically equal to, I have a lot of colors to use, so it kind of mess me up sometime. Equal to 6 to the 5th power. All right, 6 to the 5th power. All right, so give me the answers for number 5 and number 6 now, guys. And let's jump across the screen. Answer for number 5 and 6. All right. What's number 5 answer? Okay, let me see. Let's go, guys. Number 5. Google Meet, number 5. Okay, I'm seeing y to the 9th power. All right. So, hey man, so we're supposed to can jump across the addition part there right now. Because you guys are becoming a little bit more aware of what's happening. So, why? Yeah, man, but we still are going to do it because we want everybody to understand what we're going. 4 plus 5. That's just equal to y to the 9th power. Guys, if you want to learn something, just type learning in the chat right now in YouTube. If you know I learn something, if you know learn something since you come on punish the program today, I want to know text or type the word learning inside of the stream chat and in a Google Meet. Right now, if you not learn, if you not learn nothing, I got to throw down your pen. Do we have a go? Okay, learning. Perfect. That's what we are about here. once you join that show up on a Saturday 1 o'clock to 2 o'clock PDTV mathematics session. You can't miss. I will call me right now. We're not taking a call right now, because a PDTV thing we're on off right now. Best maths class on a Saturday. See, this a person I say first time learning. That is so good. What I want you guys to do also is to just type in the chat and tell me which part you know join the class from. Whether you know they are Moko, you know they are Clarendon, hold on, Clarendon's supposed to have Moko in a hit. Westmoreland, St. James, Maypen, St. Thomas, anywhere at all, you know they type it in the chat, let me see. And if you know they are foreign, PDTV Maths Session International. If you know they are England, Sweden, Singapore, I want to type it in the chat and let me know. St. Catherine, big up St. Catherine. Let's see where you guys are from. Connecticut, Valley, Ramsey, straight out of Connecticut. Benefit from PDTV Maths class right now. So let's go. Hold on. Guyana there. Guyana. Kingston. All right. Canada, New York. Hold on, man. Connecticut, Guyana, Canada, New York. Man, this is good. St. Vincent. Big up on yourself. London, UK. Learning from St. Anne. No, sir. But a maths class and a normal classes. All right, so let's zoom through number 6. When the people from England will not understand, persons from overseas who doesn't understand the word zoops. Zoops basically means that we move through a little bit quicker. So they hear me say zoops through, we're going a little bit faster. So let's get the answer for number 6, guys, and let's move over to the product law. So what's number 6 answer? Quick and fast. Number 6, 7 squared times 7 cubed. Let's go, guys. What's our result for this one? 7. So 7 to the 5th power. Perfect. We kept the 7 and we add the 2 and the 3. So that's 7 to the 5th power. Excellent. Nottingham, UK. Excellent work for you guys joining this session today. That's how we do it. 7 to the 5th. All right, let's just jump off this for 1 second. 1 second, and let's see. All right, guys, just on screen right here. For the persons who are saying that they don't have the TikTok account to access my recorded material. So what I do, as I said at the beginning of the class, whatever topic that we cover here on PDTV, in my own time, I do a comprehensive recording of multiple solutions for you guys to get it. Because even though we might finish the topic last week, we still want to have access to it. Right? So on screen here are 3 social media handles that you guys can access in order to get deeper explanation and self-paced material for the mathematics lessons. So on TikTok, I am Lincoln Maths on TikTok. Just type in Lincoln, type in Maths behind it, and you'll find me on TikTok. On Instagram, it is the same handle. Lincoln Maths on Instagram, Lincoln Maths on TikTok. And on YouTube, it is Maths Teacher Lincoln. Right? So persons in the US or in the UK might say math, but that's just an English versus British type of enunciation. So guys, so please follow the handles that I have on screen, and what you'll get from those platforms are clear math explanations. The one that I did, the lessons that I covered on algebraic factorization previously, that have been uploaded already. So if you missed the previous classes, you need to head over to TikTok, and I'm going to put it on Instagram today. and ensure that you get what you have missed. So, basic to advanced math concept building, confidence and motivation in math, support for school tests and quizzes, exam style questions, question breakdown, help building math skills, trusted math support for students and parents. So if you're a parent and you're watching, we are cater for you as well. So we guide you and you guide the student them at home, and then one big happy family we ensure so them pass them tests and them exam. All right. Jumping back to business right now. Because boss must have wonder where the rest of maths day. Come on, their maths class, you know. All right. So, second law, guys. Second law. Let me see. I'm grandparents. Perfect. Whether grandmother or mother, it works perfectly fine. All right. Where you go find them? At school too. Okay. So now our second law is the quotient law. So when you go back to maths class Monday and teacher say division, and you know that you have learned a more sophisticated term, and you say quotient, teacher have to turn up and turn around and look at who see so. When teacher said division and you say quotient, the because I have teacher no want tell the teacher say what she tell you, no make no sense, you know. You just make teacher know say you tuned into PDTV math session on Saturday and you learned another verbiage for the division, which is the quotient. So the division law or the quotient law, it's basically the opposite of the previous law. So the previous law, when we were multiplying, in the previous law, right, and the bases are the same, we simply just added the powers in the multiplication law. So if the bases are the same when we are multiplying and we add the powers, what will that be for the division? So we just flip the coin. Subtract powers when dividing same bases. Now, we explored bases already. So now, A and A, that's our bases. And now we are not multiplying, we are dividing. So when we are dividing, we keep the base. See, we still have the A right here. So we keep the base and we subtract the powers. And I miss that one here, you know. So for the first law, we kept the base at the powers because that was multiplication. Watching from London, big up yourself, Martin, watching from London. Perfect. So the first law, we were multiplying, so we kept the base and we added the power. But guess what? For this one now, that says division, we're going to keep the base, but instead of adding the powers, you're going to subtract the powers. So look at this one now. Let me see if nobody solved it already. All right, so I'm seeing flip and multiply. No, that is an important response. Flip and multiply. I know what topic you're referring to, but that's not exactly what's happening here, because we do that in the case of when we are dividing fractions. So you're not incorrect at all. All right, but that's when we are dividing fraction, we flip or do the inverse and then we multiply. All right, so looking at number 1, x to the 7th divided by x to the 3rd power. Now, I like for students to see where process in math comes from. So before we jump to the baseline of the formula, I'm gonna do something for this one that I didn't do for the previous one. It's more applicable for the division. Now, guys, remember, or if you're seeing this for the first time, x to the 7th power. All right, we're going to get to the answers shortly. Going to get to the answer shortly. So x to the 7th power. So we're going to expand these a little bit. All right. X to the 7th is basically a different way of writing this. X to the 7th is the same thing as x times x times x times x times x times x times x. Because it's a x to the 7th, so you write x 7 times. So anyway, anytime, any problem you see that has a variable in the base and a number at the top, the power at the top tells us how many times we are multiplying the base by itself. So the base is x and the 7 is the power. So the 7 tells us that we multiply the base or the x by itself 7 times. And the one about it is x times 7. That's not what it means. X to the 7th power means that you multiply x by itself 7 times. And if that means that, so the denominator that has x to the 3rd power, it just means x times x times x 3 times. All right, that's what that means. And we're going to do something here that's going to point directly to the division, to the subtraction aspect of the problem. So equal. So now we have 7 x's at the top and 3 x's below. So this is what we can do. We can use 1x from the bottom, cancel 1x from the top. We're left with 2 more x's. So 1 cancel our next one at the top. The last one at the bottom cancels our next one at the top. So the 3 x's at the bottom cancel 3 x's from the top. So now we are left with, let's see. Now we are left with x. But at 4x we have, so x to the 4th power. So that's a little bit longer, but I want you guys to know where the subtraction came from. So the subtraction came from the cancellation of the numbers. So that's where the subtraction came from. But for the rest of the problems, we can just go straight to regular programming and just get the rest of concepts out. All right. So, all right, for the persons who are saying that they want to contact me through WhatsApp. All right, guys. If you see the link, the Google Meet link, you can just access the Google Meet session and send me a message in Google Meet, and we can exchange credentials. Perfect. Me understand it. Somebody said them understand it. That's nice. If one person understand, then PDTV do a good job today. At least one. At least one. So let's now move on to number 2. So 2, all right, 5 to the 6th power divided by 5 square. Let's go, guys. You guys got this one. You guys got this. So what's our answer? All right, so I'm seeing 5 to the 4th. Perfect, because the bases are the same. So we keep the base and we subtract the powers. So basically what we did was this: 5, 6 minus 2. And that's just 5 to the 4th power. And in upcoming lessons, we're going to be expanding index numbers in terms of multiplications, just like how we did x to the 7, and that is equal to x multiplied by itself 7 times. We're going to expand these type of results. But we're keeping it simple for the first day, and then we move on. So, okay. 7 to the 5th. Okay, so now for number 3, 4, 5, and 6, I want you guys to think of 2 questions that looks like number 1 and 2 that looks like number 2. So let's go, guys. 2 questions that look like number 1 and 2 questions that look like number 2. Let's go. All right. Sharon, 5 to the 4th power. Perfect. Let's go, guys. So we need 2 examples that looks like number 1. Well, similar to number 1 and 2 that are similar to number 2. And those will cover 3, 4, 5, and 6. Let's see what's happening in Google Meet. Google Meet tend to use they don't like to talk that much, but may I get them to talk. So let me see what I go on for Google Meet now. Okay, well. Panama, big up yourself, Panama. Dolores, Logan, Panama, perfect. Nice. Jada Burrows, Minnesota. Nice. That's cool. All right, guys, big up. So let's grab our other 4 examples. So what if you got 2 whole numbers in the question? All right, 2 whole numbers. Let me see who is asking that. Yes, somebody named Biggs. So are you referring to 2 whole numbers in terms of, for example, 3/5, or let's say 8/2? Please let me know if that's what you're referring to in terms of 2 whole numbers. In the meantime, let's take the rest of the problem. So, Ramsey, m to the 4th divided by m squared. All right. So m to the 4th power divided by m squared. Let's go, guys. 4, 5, and 6. You guys doing extremely well. And guys, listen up. Giveaways are coming up. All right. We're going to be doing some giveaways. So regardless of your location, whatever can be rewarded to you, whether Jamaica or overseas, we figure that out. Whatever you guys can get as a reward, that's actually in the making. All right, so I'm gonna put it to the team so we can reward you guys for your cooperativeness and good behavior. All right, 7 to the 4th divided by 7 cube. Nice. So 7 to the 4th divided by 7 cube. All right, m to the 2nd power. So Sharon, I'm seeing m to the 2nd power. What else we need for that one? Oh, you're giving me the answer for number 3. Okay, I get it, Sharon. So we need 2 more, 1 for 5 and 1 for 6. Let's go, guys. 1 for number 5, 1 for number 6. All right, so let's get 3 and 4 out of the way. All right, so m to the 4th power divided by m squared. If we should, all right, so the direct subtraction, we know so that's simple already. That's pretty straightforward and simple. Let's go the expansion method where we did it similar to number 1. So if we're doing number 3 like number 1, how many m's will I have in my numerator at the top? So we know so it's easy for just subtract 2 from 4 and you get your number. But let's say we are doing the expansion procedure that we did at number 1. So somebody said we're gonna have 4m. All right, let me see. No problem. All right, so somebody said we're gonna have 4m. All right, so we're gonna have, perfect. So m times m times m times m. If somebody send me for right bigger. All right, we're gonna have 4 m's at the top, and for the numerator, it's just m squared or m to the 2nd power. So we're just gonna have m 2 times m and m. Perfect. So something that I want us to understand, even though there are 4 mathematical operators, addition, subtraction, multiplication, and division, if you think about it, guys, there are only 2. And you'll see why they pair them in such a way. They're just two operations. Even though primary school teacher tell you, say, oh, we got multiplication, addition, division, and subtraction. If you look into it more mathematical, there are only two. Reason being, multiplication is just repeated addition. If you get what I mean. Multiplication is just repeated addition. So let's say we multiply the number. Let's say we multiply the number 2 by 4. Let's say we multiply 2 by 4. All this is saying is this. Repeated addition is just 2 plus 2 plus 2 plus 2. 4 times 2, 8. 2 plus 2 plus 2 plus 2 equals 8. So that is why they tie the multiplication and the addition together to form the rules. All right, so in this scenario where we are subtracting, where we are dividing our expanded forms, we will simply just m cancels m, m cancels m. So the two m's at the bottom cancel 2m from the top. All right, so now it's just a case where we have 2 m's. So this means that m will be in our base and the 2 is at the top. And people have been sending in that response already. So you guys well on the way. Right, let's look at number 4. Number 4, Google Meet. Let's get in our responses on number 4. Yeah, we're doing the expanding method, guys. We're not just gonna jump and say 4 take away 3 equals 1. We're gonna be doing the expansion model, because doing it that way, you'll see what is behind the curtain. When the teacher just say, here, 4 take away 3 left 1, so that's 7 to the first power, or 7. When you're doing your tests or your exams, you can put down all the procedure. So if you perform this expansion method, and even if the answer wrong, you're going to get your marks same way, because you carried out the procedures. So equal, I'm seeing, okay, 7 times 7 times 7 times 7, perfect, divided by 7 times 7. All right. Okay, so the denominator is 7 cubed. Right? So expanding, we're going to have our 7 times 7 times 7 times 7. All right? Because remember, we have 7 4 times because we have a 4 at the top. So that's what it means. 7 to the 4th does not mean 7 times 4. And what it means? It means 7 multiplied by itself 4 times. So that's the numerator. The denominator is 7 cubed. It is not 7 times 3. We multiply 7 by itself 3 times. So 7 times 7 times 7. Right? Once that is done, we can simply go ahead and do the required cancellation. So we got 3 7s at the bottom, 4 7s at the top. So all 3 below can cancel 3 from the top. So all we are now left with is 7, so equals 7, and it's just 1 7 that is there. So that means it is 7 to the first power, or just 7. All right, so 7 to the first power is the same thing as 7. So every number that you see in math, let's say we see 1, we see 2, we see 3, 4, and so on. Any number that you come across in math or variable, if it seems as if it is by itself, it always has a power of 1. All right. So we just say that is the invisible one. It always has a power of 1. I just want you guys to see what's happening here. Oh, I didn't see the 3. Come, stream chat. Let me see. Learning. Come, make me see what I go on. Put the emoji them in the chat. If you learn, let me see what I go on. Come, let me see the learning being typed and the emojis liven up the chat. Persons who want to reach out. Okay, somebody. So if you want to reach out, for example, the person who said that they want to reach me on WhatsApp, please join the Google Meet session and then we can exchange the info there. Perfect. We know learning I go on, man. Nice topic this. And this I go set you up now for get some better understanding of higher order math material. Guys, remember, I want you guys to be benefiting from my teaching right around the clock. All right, so remember, I'm on TikTok and I'm on Instagram, and I also have tons of videos on YouTube. If you want to explore more math content, math material, get math help, listen, if your teacher tell you, say, hey, you need to get this piece of assignment done. If you have a question, just send it, come give Mr. Thompson, so I can guide you and see what is the best move forward. So, law 3, we're going to scratch the surface for law 3 because let's have a few minutes to go. So law 3 says, power of a power. Yeah, that might sound bizarre, but it's just a power of a power. Multiply, it just multiply powers together. That's all it is saying. So let's say we have 2 quantities. In bracket, we have, let's say in bracket, we have something like this. A number raised to a power in bracket. And all of that inside the bracket is actually raised to another power. All right. In this case, a to the m is raised to the power of n. Yeah, man. So we don't only raise a single quantity to a power. We can also, let's see. We can also raise a number that was raised to a power to another power, if you know what I mean. So in this case, we just multiply the powers, that's all. Or the indices, that's why it's called laws of indices. We simply just multiply the indices, all right? So in this case, a to the power of n raised to the n power. You notice here, we kept the a and we multiplied the powers at the top. So guys, they are probably, we're going to touch on probably 8 laws. These are the first 3. So you should have been taking notes or doing the screenshot type of thing to ensure that you remember. All right, so let's wrap this one up. So for this one, simple. So x cubed to the power of 2, or x cubed raised to the power of 2, we simply just keep the x and then we multiply the powers. So 3 times 2. So x cubed to the power of 2 is equal to x to the 6th power. Right? That's just another fancy way. So you see how math's kind of tricky. So x to the 6th power is just a way of writing this thing right here. Yeah, that's maths. Maths have some very simple ways of representing complex machinery. All right. So since this one is probably the simpler one out of our 3 laws, what's the answer for number 2? Answer for number 2. So 4 squared all raised to the power of 3, or 4 square cube. What's our, all right, so let me see. Okay, perfect. 4 to the power of 6, that's from YouTube. So we have our 4, nice, and then we say 2 times 3, that gives us 4 to the power of 6. Perfect. All right, so two problems that looks like number 1, 2 problems that look like number 2. I'm wrapping things up right now. So let's go, guys. 2 problems that is similar to number 1, and 2 problems that, well, that are similar to number 1, and 2 that are similar to number 2. Let's go, guys. YouTube, let's go. Google Meet, let's go. 2 minutes and wrap things up, guys. All right, 1 that looks like number 1, 1 that looks like number 2. So we can finish up 3 and 4. Come, guys, let's come. Examples. Let's see what is happening in Google Meet right here. All right, perfect. All right, so I see somebody just sent us something. Let's write that down. So wait, let me expand my screen. Perfect. So an example that we got was, all right, 5 to the, or 5 square, all raised to the 4th power. That's perfect. And for number 4, we have, all right, y to the 7th power, all raised to the power of 2. All right, that's fine. So come, guys, answer for 3 and 4. What's the result for 3 and 4? So number 3, 5 to the 8th power, perfect, because we had 5 square and we simply multiply the powers. 2 times 4 equals 5 to the 8th power. Excellent. What's number 4? All right, let me just put this one at number 5. Okay, yeah, 5 to the 8th. All right, guys, let's solve number 4. And number 4, y to the 14th power. Let's check that. So y, we multiply the powers. That's 7 times 2. That is indeed y to the 14th power. Excellent work, guys. You guys have been doing so good. And remember, the topic is a bit fresh. When the topic is fresh, you want to grab it while you can, because once we start to progress a little bit more faster, things might slip away a little bit. So on screen here, I'm going to just take a minute to keep this up. For the persons who have access to TikTok, Instagram, that's my handle to access extensive mathematics material. And that's also a place where you can send me a message to ask me a question. Persons who want to be a part of my tutoring program, because I do have tutoring sessions outside of the Saturday PDTV sessions. If you think you need a more direct type of communication solution, math assistance, you can message me on TikTok or Instagram, and we will make the arrangement from there. You see somebody saying East Indian mangoes. Okay, that's good. All right, guys, so I'm gonna leave this up and we're going to wrap this up right now. So guys, it was a pleasure having you here today, and please join us again in future classes at 1 to 2 p.m. on Saturday on PDTV mathematics session. All right, so Google Meet, YouTube, stream space. Have a wonderful Saturday. All right, guys, take care.
High schoolers, level up your brain. PDTV Maths sessions every Saturday. Algebra, fractions, equations, functions, all made simple, all made fun. So you all jump on the bus, let's go to where your future is bright. Matter what we say, matter what we need. No game, no gimmicks, just knowledge we are defend. What not draw TV, matter we love.